Welcome to this video on chemical bonding. I am Arnold Villaro, and you can reach me at the email address provided on the screen. Chemical bonding is defined as the joining of two or more atoms to attain stability, with the atoms connected by a chemical bond. Atoms bond for several reasons: to attain stability, to attain low potential energy, and to experience more attractive forces. Atoms achieve stability by either losing electrons, gaining electrons, or sharing electrons with other atoms. The term localized refers to an object that is unstable, has high potential energy, and experiences less attractive force. Conversely, delocalized refers to an object that is stable, has low potential energy, and experiences more attractive forces. The three main types of chemical bonding we will discuss are ionic bonding, covalent bonding, and metallic bonding. Ionic bonding, also known as electrovalent bonding, involves the losing and gaining of electrons between atoms. An example of an ionic bond is sodium chloride, sodium chloride. Note that ionic bonds are typically formed between metals and nonmetals. This diagram illustrates the transfer of electrons in ionic bonding between sodium and chlorine. For practice, you can attempt to draw a dot and cross diagram for the ionic bonding of magnesium chloride, LiF, and CaO. Ionic compounds are characterized by high intermolecular forces, being electrolytes, solubility in water, being made up of ions, and having high melting and boiling points. Covalent bonding is the type of bonding that involves the sharing of electrons between atoms. The three main types of covalent bonding are single covalent bonds, double covalent bonds, and triple covalent bonds. A single covalent bond involves two electrons and uses a single bond to connect the atoms. The hydrogen molecule, H2, with the structure HH, is an example of a single covalent bond. A double covalent bond involves four electrons and uses two bonds to connect the atoms. The oxygen molecule, O2, with the structure O equals O, is an example of a double covalent bond. A triple covalent bond involves six electrons and uses three bonds to connect the atoms. For example, the nitrogen molecule, N2, features a triple covalent bond. A polar covalent bond forms when electrons are not shared equally between the atoms. This diagram illustrates an example of a polar covalent bond. A non-polar covalent bond is formed when electrons are equally shared between the atoms. This equal sharing occurs when atoms have the same electronegativity, as seen in the hydrogen HH and chlorine ClCl molecules. Covalent compounds typically have low intermolecular forces, are non-electrolytes, are not soluble in water, are made up of molecules, and have low melting and boiling points. Metallic bonding involves metals only, where delocalized electrons are attracted to positively charged metal ions. This diagram visually represents the concept of metallic bonding. Metallic compounds are good conductors of heat and electricity. They are sonorous, meaning they produce a ringing sound, and ductile, meaning they can be drawn into wires. Finally, metallic compounds are malleable, meaning they can be hammered into different shapes, and they have high melting and boiling points.